Okay, sounds good.
All right, let me invite you. Yeah, go ahead and use this link. Be aware that the name you put in there will be visible to other people as
Okay,
well.
all good.
All right, so let me just have a look here just to confirm. Uh, okay, looks right. Okay, all right.
Um, yeah, all good.
Okay, great, Carlitos. So let's get right into it then. So again, welcome to the mock interviews. Do you know how these work roughly?
Wait, what?
Do you know how these mock interviews typically work? So I can explain it really quickly. It's gonna be an
Oh, yeah,
hour long
yeah.
session. Okay, it's gonna be an hour
Mhm.
long, and then we're gonna spend about 45 to 50 minutes or so on the technical portion. The time management there is for you to control. So that's for something to, for you to be aware of. And of course, afterwards, 10, 50 minutes, we'll leave for questions, feedback, etc. So, what's your preferred coding language? Hey, are you able to hear me? Oh, looks like we might have a bit of a audio issue on this side. Can you hear me? Okay, looks like we're having audio issues. We'll be back in a minute. Can always happen. Let me go ahead and pin the Malcolm V sign up form.
It's kind of weird. Hello?
Oh, you sound better now.
Oh, okay. That's kind of weird. I just disconnected my headphones and it messed up, I think, something.
Well, welcome back. Let's get back into it. So, what did you miss? What did you hear?
Oh, I heard that it's gonna be 1 hour and then at the end it's gonna be questions,
Yeah.
right?
All right. Let's.
Then yeah.
Sounds good to me. All right, let's get into it then. Yeah. So, what's your preferred coding language?
Oh, Java.
Java. Okay, we'll switch to Java. No problem. Where is Java? Java. Am I blind? Here's Java. Here we go. Okay, great. So let's get into it then. So just to confirm, we're doing leet code. We're doing intern hard. Yes.
Oh, it's a hard one.
Well, that's what you put. Do you want to change it?
um, yeah, maybe a little bit if it's possible.
Yeah.
I
Well,
don't
yeah.
remember what I put for last time. Yeah.
Well, you put intern hard. What do you want?
Medium will be good.
Okay, great. We'll do medium. All right. So I'll read you the prompt and then we'll get right into it. So today's problem is being called network delay time. Okay, I would like you to write me a function called find a delay. It's going to take in a list of edges. These are directed edges in the
Mm-hmm.
form of three numbers. So that's going to be the source node, destination node, and the weight.
Mm-hmm.
Okay, and then you'll also be given a source node. Okay,
Okay.
and so you want to return the minimum time it takes for all the nodes in the graph to receive a signal from the source node.
Can I see the prompt or?
Nope, but you're free to ask questions about it.
Oh, okay. It's not like I can see the prompt and oh, okay. I have to ask you questions as we go.
That's right.
Oh, okay. So you're telling me I'm gonna get a list of edges, free properties, source, destiny, and weight. I guess it's gonna be a list of sources
It's
or a
it's list of list.
list of lists. Oh, so it's a list of lists, and each of the sub items in the main list is a list of free items, I guess.
Yes, that's right.
Okay, and then source, I guess, is an integer, is a string, is a
It's integer. Yeah.
integer. Then all of them are also integers, I guess.
The weight might not be.
The weight is what would weight be then?
It would be a double precision floating point number.
Okay, it will be a double. Makes sense. And then I'm getting this things, and I'm getting just that. And then what's the outcome we want?
The output is the minimum time it takes for all nodes in the graph to receive a signal from the source node, from the given source node.
So min time that all nodes receive. So you get a list of edges, you get a list of lists, and we want to find the minimum time that each node.
Return the
Right,
minimum time it takes for all nodes in the graph to receive a signal from the given source node.
okay, for all nodes in graph receive to receive a signal. And then this nodes, so I'm getting a list of lists, and I'm getting also a source, I guess. That's the second parameter I'm getting.
That's right. You're given also a source.
And then the source has only, I guess, is only one integer, I guess.
Yes, it's an integer,
Or
which is an integer representing a node, a specific node.
okay, and that node has like some kind of link to other nodes, I guess, like a next or something, or it's
Yeah, you can assume that there is a correct answer. You can assume that the graph is connected. Yes.
the graph is connected. But like in what way? Like how can I see if one node is connected to the other one?
Because it'll
Is
be in
it
a list of edges.
oh the list of edge? Oh right, because you have a source in this thing. My bad. Okay, that makes sense. So I guess I have to build some data structure that allows me to visualize all the graph, all the nodes. I guess this would be my brute force approach. Something like I just do a for loop over all the nodes, and then um have something like a hash map maybe, where key is the source, so an integer, and then the value would be like a list of the destinies this specific node has connections to.
Okay.
And and I guess when you say that the source and a destiny have a link, is it like both ways? I guess like can you go from source to destiny, from destiny to source?
No, it's a directed graph.
Oh,
So no.
directed graph. My
Yes.
bad. Okay. So I just assumed that. Okay, and then so I'll like so I guess that could work. And then once you have that hash map with a key and a list of values that it connects to, what next would be um could be minimum time that each node receives graphs. I'll receive the signal from the key. And I have the key. Mm, and then I will have to use some kind of data structure that allows me to find the minimum time. Mm, mm. Oh no, stream after receive the signal. How could I implement this? So from my understanding, like I guess that first approach of creating the hash map of keys and lists that would be valid for this case, I guess.
Can you
Like at
elaborate
least
on
for
what
the
the
brute
hash map will
force.
be?
So the hash map would have a key as key the source,
Okay.
and then its value would be a list of nodes, which are the direct links from that source to the other nodes. Because I guess every node can be connected in different ways, right?
Sure. Yeah.
Like
Yeah.
one, yeah, and then from there, I could start from by searching the specific key. Like for example, I would get the values of the source that I want to find out, where all nodes in the graph receive a signal, and then start from that node, and then get its values. So I would get a list of those values, and then from there, every single time I would access something, the list, um, every single time I would access a node in the list, I would add it to a set, something to keep track that I already accessed a specific node previously. I guess every node is gonna be unique, right?
What do you mean by that?
Like could I have a like every node would be unique? Would it have a unique integer? I guess representing it.
Yes.
And in that case, I could keep track of that in a set, so I can just know like how many nodes I have that I have like search where I would use I'm doing the search, and then from there go for each of those nodes that have in the value, and then um I don't know the retracing.
Just to be clear here, do you understand what we're returning?
It's I guess an integer value,
It could be a double, but
right?
yes.
Could be a double. Is it not the time what we want?
It is the time we want, yes.
And the top. Oh, in the wait. So what does wait mean then? Wait means the amount of time it takes
Yes.
to go from one node to the other one.
Yes, that's right, yeah.
Oh, okay. So um then I could have multiple. Let's see. So 8, 7. So maybe I can see my screen. Mm. Can I just put my thoughts here in the code pad maybe?
I definitely encourage it.
Okay. So I would have, let's say, node. Can I start from here? How can I do that? Oh, well, okay. So I have my node would have parameters like, let's say, 1, 2, 3. 1, 2, 3. Let's say we have 2, 4, 3, and then one more that, let's say, is something like 3, 3, 1, 1. So in this case, the how it would look like technically, if we build a graph of hash maps of key and values, would be something like, hey, I have my source, which will have a list, which in this case will have only the item 2, and oh, I have to keep in mind the weight too, from 1 to 2. So how would I do that? I could do probably in the like the hash map would be a list, and then the list would have basically the destiny plus the weight, so something like this, and then that would allow me to keep track of the time it takes to get to that specific node from that specific item, from the specific source. So in that case, we will have that, and then for the other one, we will have something like 2. We have a 4. That's the destiny and a weight of 3 again. And then lastly, we have like this 3. It goes from 1 comma 1 because it's the time it takes. So if we have this structure done, and we have this source, let's say we start at 3, for example,
Okay.
and I wanna go from I wanna know the minimum time where I signal all the nodes. So I guess if the actual answer for this would be basically something like 3 to 1, it would take 1 second, so we have 1. Then from 1 you can access 2, and and by doing so you need to use 3 weight, so that's the plus 3. And then if you are in source, if you're now in your source node 2, and you want to access 4 because that's the last item you want to access, you have to do a plus 3, and that way you know, and that the end result that you want for this minimum time would be 7. I guess that's the right for this case, that would be the right answer, right?
Yeah, I think so, yeah.
So in that case, um like the way I would do it would be, and could, for example, let's say I have something like here where I have from 1 to 4. I have something like 4 here in my list of lists. If I have that if I have the source 1 and the destiny 4 with a weight of 4, does that mean I have this, I guess, something like 4 destiny, 4 weight? So let's say in this situation where I was at this point, I get to, for example, I got to source 1 already, and I wanna go over these two paths. Are these two paths gonna go in simultaneous, or is it gonna go like one, one,
What do you mean by
or they're gonna go in
simultaneous?
parallel? So that would mean I will take the minimum from the weights of all of these ones, right?
Well, not necessarily. It depends on whether the subsequent subproblems are in aggregate cheaper.
Oh, I
So
guess that's true. Um, so it's something I'll have to start from. Hmm. Mm, mm, do you have some kind of hint? Maybe I could. Maybe I'm might be missing something.
yeah, sure.
Like I'm trying to. Yeah.
Yeah, so this problem is essentially a you can think of it almost as a flood fill, where from the source node you can
Mhm.
take all paths, and then you don't necessarily have to care about the weights. But if you're somehow able to track that you've gotten to a node, any node in the shortest time to that node, then you know you've gotten the correct answer once you've visited all the nodes in the graph.
Hmm. But don't I wanna visit all the nodes now of
Yeah,
the
you do want to
graph?
visit. Yeah, you do want to visit it. Yeah.
So I'm trying to think of it like, like because if I use BFS wouldn't necessarily give me the minimum time with all of them. Although, what do you do? If I go start from
Can you
source and
elaborate on that?
so if I go from the source, starting and apply BFS,
Yeah.
I'll I'll go over each of the node values and then separately keep track of the time, I guess. And then
What do you mean by separately?
like every single one of them, like let's say
What's
I
that?
call BFS of 3 because that's where I'm starting.
Yep.
BFS 3 is gonna call then afterwards BFS of 1, and then this one is gonna keep track of the count at this point, right? Let's say like what if we had something else here? Let's say something like 2, 3,
Yep.
right? In that case, the count for that one would be BFS2, and the count at that point would be 3. Um, and then as it expands, um, we will get each one of them are gonna have some sort of time, right?
Yeah, that's true. But why is that a problem?
I'm trying to think like because like what if one BFS finishes and I have some specific value and that's where it ends? So I'm trying to figure out like how could I. Well, I guess wouldn't the biggest amount from all of the BFS be the minimum time it takes to like go over all the nodes?
It depends on how it's implemented, but it's definitely possible to do it as such.
Because technically, if you run all the BFS and you keep a global counter, let's say
Okay.
a global counter, and you go over all of this once, and then you start at this point, go over this one, and let's say you call something like 3, you keep 4, and then it ends here because that's where it took you to nothing else. This is like the leaf of the graph that's in some part of the graph, and at that point the total count would be 5. If this one continue, for example, going from 3 to EFS like 5, and then it keeps going and it keeps accumulating counts, it will get some count of like, for example, 9. And what matters at the end is the minimum time you want for you to find all like the minimum time to where all the nodes have been signaled at some point.
Yes.
So at this point, it got finished. But then at this point, it also got finished. But this one, at this point, you already finished this part and you also finished this part. So technically, this would tell you that this last item that's not in the set that I'm keeping track of the unique nodes is gonna tell me that, or well, the set wouldn't work because there's multiple ones that go. But
Well, I
like,
like your
yeah, I
idea of the
guess.
global counter. Okay, how about we do this? How about you have, and I'm not saying I have it global, right? So you have to decide how to split
Yeah.
that. But why don't we just have a way to say min times, and then your key will be the node, and the value will be the min time so far to get to this node.
Oh, so far to get to this node. Oh, so for each one of the operations, do a min time, I guess.
Yeah. So for example, if you're trying to do BFS, I'm trying to follow your logic here again. Trying to do BFS, let's say from 3 we go to node 2 with cost 3,
Yeah.
right? You got to So I'll do it like this. So let's say, right? So we do BFS 3, right? We're gonna say min time for 2 equals 3. I'll just call it min for now, okay? And min
Oh,
for
okay.
1 will be equal to 1, okay?
The minimum one for one would be, well, yeah.
Does that make sense? And
Yeah,
then
yeah, that
and then
makes
you
sense.
continue your logic. So BFS 3 will do then BFS 2 and BFS 1, right? So when you do
Yeah.
BFS 2 can go to 4 at cost 3 plus the current cost, right? So min 4 will equal min 2 plus 3 equals 6, right?
Oh, I see, yeah.
And then for BFS one, you would do BFS one will do min of 2, and you also set min of 4. So min of 2 equals min 1 plus cost of 2 from 1, which is 3, right? Which
Mm-hmm.
is equal to 4, right? And min 4 will equal what? Min 4 will equal what? Will equal, so min 1 plus cost of 4, which is 4, which is 5.
Mm-hmm. Okay, so yeah, you're keeping track of each one of them. And then, but then if, min 4, so BF2, min 4, min 2. So what you're saying is, for this BFS2, for example, you had in this case 3, you added the minimum to get to 2, you added a plus 3 weight, which is 6, and that was the value for the minimum 4. The minimum 4. But what would minimum 4 be here though?
What's that mean? Wait, sorry, what do you say?
Like this minimum 4 here. Like I understand this part. Like this is what you call for BFS2,
Yeah,
that plus 3 because that's the weight. You get 6,
yep.
but then you're assigning this to minimum 4.
Where am I assigning what to minimum 4? Sorry, I can't see your. Yeah, so this is minimum
Yeah,
4 because
well,
from BFS two from 2 we can go to 4, right?
oh, right. Okay, so okay, that makes
From 2 can
sense.
go to 4, and the cost to go to 4 from 2 is 3. So that's what you
Yeah,
say
yeah,
the cost to go from our original node, which is 3 to 4, is the cost to go to 2 plus the cost to go to 4, which is 6.
right.
And then here's the
Oh,
key. The key is that when we do BFS one, we notice that we can also go to 4. And the
yes,
cost to
right,
go to a 4 from 1 is cheaper because this is 5 and this is 6. So we
right.
overwrite the 6 with 5 because it only takes 5 to go there, to go to 1 from 3. To go to 4 from
Right,
3.
right. But wouldn't I have to do a check beforehand here?
Yeah,
Like,
I did it in my head just to show you that this is 5 and this is 6, so we overwrite it. We just put 5 here.
yeah, but in reality, I will have to do some kind of check that the value you're overriding is an actual minimum.
Well, yeah, yes, of course. I'm not giving the full implementation. I'm just giving the idea.
Right. That makes sense. Um, okay, and then at the end, when I have this result, I will have the min times, let's say, the node, and it will be something like um to get to like one, like the first one is 0 because you have, yeah, like let's say for now it's 0. Then for the second it will be 1. For the third one, it would be, the minimum would be 3, and then for the third one, there's no third one, I guess. Oh no, I do have a third one. But okay, so with this approach, the value, let's say something like this. And then with this value itself, have the minimum for each one to get. Um, but wouldn't all of them need to be in the sequential order either way though?
Say again?
Like if I do this approach like this,
Yeah.
um, then in that case, um, I'm not guaranteed that the that it all follows a sequential order, right? Shouldn't it all follow sequential order, or this is just in disorder, I guess?
What do you mean by sequential order? I was trying to understand.
Because would it like to signal all the nodes?
Yeah.
It would have to follow, let's say, from node one to node, like something like node one, node two, and also node three, and then node two would go something like to four, and then node three will have to go something like, let's say, back to one. No, it cannot go back to one, but back to five, for example. So it will go from here, here. Ah, no, never mind. Um, the
Yeah,
minimum time
there's
would be the adding of all these min times.
no, it would be 5 in this case.
Oh, the last one. Oh, so it's like oh. Also,
Sorry, what do you mean by
this
last
is
one?
the, no, no, like I think I got confused. Then the minimum time would be the last cell of the min times node.
Not necessarily.
Not necessarily.
Nope. For example, you could replace 4 here. You can replace 4 here with a different number. Let's call it, let's not do it this way. You can replace 4 with, for example, 0.
Yeah.
And this will still be a valid problem. And now this would be 5, and this will not be a node anymore. In this case, the answer would still be 5.
Oh, so would it be the maximum value
Yes.
from the array? Oh, okay. So I would have to implement this logic and then find the maximum of the array. And I guess there's a better way probably with. I guess this is a DP.
Doesn't have to be.
Mm-hmm.
DP would make it too complicated. I think you can
Yeah.
start with a pretty standard BFS based solution.
Okay. I mean, I can maybe try it out and see if I can build it. See it goes.
Sure.
Okay, so I guess I will have first do the class.
You could use the class above.
Sorry.
You could use the class above. You can just reuse it if you want.
Oh, where's the class? Oh, my bad. Okay, so you have the main here. Um,
I do
I will
encourage you to
have
write another function. You can start a function somewhere. Yeah.
um, so let's call it something like public. Um, what would I return from the BFS? I would return. Well, technically, I could return nothing for now, and then I can add a return later. Then in the main, I would have the min times node. I think I'll create the array list. Which will be min times, and then once I have the array set up,
I'm gonna go ahead
I'll
and give you
have
this.
the source as it. Right?
I'd like you to implement this function.
Oh, okay. 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 Oh, right. Because you're giving me the double times. Um. Yeah. So do you want me to call it from the main though? Everything?
No, don't
At the
bother
end?
calling it.
Okay. I thought okay. So then, you get the delay times, you get the double times, and then let's say I have my this one, and then here in this network delay time, I'm gonna be calling a BFS, which is gonna will be called like recursively. This one is gonna accept the array list of integer min times, and also would probably accept the specific source, which in this case would be double times, wait, double times source. What's this? No times. Oh, this is the array of arrays, and this is the source. Okay, okay. Yeah, so I guess first I will have to build my hash map. That oh no, I don't need to because where I do need no, I do need to do it still. So I'll just build it for now and see if it works out. So I have my hash map, which would have times. Oh, so is the source and destiny now doubles?
No, they're just integers in a double format because in Java you can't have mixed type arrays. So the weights are doubles and the integer and source nodes are integers.
Okay, so do you want me to keep track of them as integers, or should I keep track of them as doubles, or should I just cast
I
them
don't care how you
to
implement them.
integer?
I don't actually care. Yeah, it's up to you.
Okay, okay. I'll just for now just do double, which is the destiny, and then the list of heirs. Um, I'll just do a list. Oh well, do I need to do this though? Yeah, for now I'll just do it, and then um, and then have a map, which would be the one I'm gonna be creating, be at the times. So for each um double piece, I will have something like times. And then for each one of them, I'm gonna be doing basically a map dot um um add, well it will be map dot compute, and then compute if the key exists. Oh, the key in this case would be the first element from the time properties. Yeah, because of the weight. Um, so time properties dot zero, which in this case is the first one. Yeah, and then I would check. I forgot the annotation for this. Uh, can I check the documentation quickly?
Check the what?
I
Oh yeah. Go
The
ahead.
documentation quick. Yeah, I haven't coded like these things in 4 months, so I'm kind of rusty still. Uh,
Well, for the sake of time, why don't you just make up syntax and assume it works? I don't care about syntax.
okay, okay, fair enough. So it's just basically map dot compute the key, check if it's null, and then um, God, it's something like this. Like if it's we null, then in that case we're gonna add this, and then this would be basically a pair of the time properties um the source, the destiny, and then the weight, and then the weight time properties, um, and then the weight, and then once I compute that, I would just go over this hash map, then and then as soon as that BFS is done, then I would be able to um, have this approach that I want to do of of the oh, of the hash things, and then from there I will call BFS. Well, I will get the specific node from the map. So in this case, something like let's just to start, just to have some reference, I will do something um like list of of list. Oh my god, list double, and then I will get the first list, which will be mapped dot get, and then it will be the source, and then I will get this list, and I would just traverse it, but that will have to happen in the BFS, I guess. So we just do a BFS where we'll be passing a specific source. So I'll have to add here source, which would be like an integer, I guess, source. And then this inside the BFS, I would basically be traversing over the entire list. So I could probably do it with a queue, I think. Yeah, I think a queue is the way. Uh, yeah, a queue where I would first have an empty queue, I guess. No, wait. So, um, wait. Ah, let's see. Um, yeah. So, yeah, you did a queue, and then the way the BFS worked, like, added to the queue and then popped met, and then from popping it, I would search the other ones, and then after doing that action, I would do so. If I'm getting the source, I want to access the values from the hash map, right? So I'll pass for now the hash map values that I got from here into the BFS. So BFS calls, passes the min times, passes the source, passes the hash map that I created. So I have the hash map, which I wouldn't just declare for now, but I'll just keep it like this. And then as soon as I get the source, I will get basically, I will do this operation I did at the beginning of map.get source. And then what I would do would be basically um, add all of them to the queue. So do a for loop of item, item in list, and then have the first list, and then basically add it to a queue that I created. Double queue new all right, the queue I can do for example for now, and then I would add it to the queue dot add item list, because the first lead item in list, and I would add the specific source in the queue, right? And then I will do something like for while queue is not empty, it's empty. You can just get from the queue and pull one double, which is the specific item that I want to do a DFS on. And then I have to do some operation here also as well, which would be the operation of the min times I was implementing here. But first, I'm just gonna declare just to have an understanding that I'm going in the right path. So I'm having the source, have the queues empty. No, well, I wouldn't care about the first item. I would care about the, yeah, no, the first item is the destiny. So from this one to this one, I have a destiny, which I'll add as a pair. So I'll add to the queue a pair, which would be that pair from the list of, a list double, and then I would access those two items, get that item after. So get this list double, and then pass this pair, which would be pulled from this one. And then once you pull it, you have it, you remove it from the queue, and this queue is basically going to do this operation of updating the min times. So the min times, what we want to do in this case is, so in this case, we're gonna simulate that we're gonna do a BFS of free, for example, and by doing this, the BFS of free, we wanted to do, we want to go over, we want to update the minimum of 1 and 2. So we want to do that, then source destiny. Yeah, destiny, we will get the pair dot 0, which was the destiny, and update it with the minimum, the math dot min of this same thing. Math dot minimum of this one with the min times pair, min times pair 0, but in this one we're gonna simulate the plus of the weight, which in this case would be the pair dot 1. And then that would update, and we would get, that way we would get the minimum for each of the min times. And then after doing the operation, we want to call BFS, but for that specific destiny, for that specific item. So it will be something like BFS min times source map, and then we would be getting that value each time we do this, and then do this operation again. And then at the end of the day, what we want to do is, after we get this, we're gonna get a min times value, which is gonna be the integer, and then for each integer, we're gonna do min times, and then we're just gonna find a maximum value, like a math, like a max value, integer, max value. And then that would basically, I think I wrote things that are not even relevant, but I'll remove them as I go. And then, yeah, I just find a math dot, like max value. Math dot max value, and then integer, and then return at the end the specific max value that I get. And I guess that could work, but I feel like there's something off here. I'm doing DFS. Oh, yeah, well, queue's empty. Well, I already added to a queue. I guess, would this work? This idea work at the end?
The idea would definitely work. How's your implementation look? Are you
The
confident in it?
implementation looks horrible right now, but
Okay.
no. I can probably improve, but implementation makes sense then in this case.
The implementation has a couple questions in it, I would say, but the idea is definitely there. Yeah.
Yeah, I feel like the main issue is, I'm trying to think. So I have this. Okay, so from the beginning, I'm computing the hash map, getting a map, getting the list of doubles. This list of doubles helping me do the BFS operation, but the BFS operation I'm not doing it properly. Um, and that's the issue, because I'm trying to think like how I used to do this thing. Um, have the list. The list could technically act like the queue instead of creating a new queue from scratch. Okay, let's see. List, double, item list, first list, item list. You have a queue. You have this queue. While queue is empty, you pull, you pull, you pull, and you keep elaborating over one over one, arrow CS. And this part here, I can do something like compute if absent maybe. app.compute absent good time properties 0, and then do something like new array list. Oh, right, I forgot new array list. That's how you did it. And then once I had this, I could add it to that list. Add add new array list with specific value, which would be arrays, maybe arrays as list. Yeah, because it's gonna be fixed. No, well, it's not gonna be fixed. I can put it for now. Time properties. 1 time properties 2, and then this technically shouldn't be red now. And maybe do this. Okay. So okay, fair. So I have this firstly don't need anymore. So we have the min times, which I pass to the BFS. BFS does this operation here, where it gets the list, where it gets the source. The source itself gets the first list, and this first list is added to a queue, from which this queue is basically pulled every single time, so that we can find the minimum time for each destiny. That way we're calculating. Sorry. So in this one, we have basically min times of the destiny is equal to the math minimum of the current minimum destiny that we have at this point. Although, would it be min though? Actually, wait. Wait, I think I'm. Yeah, I guess it would be min for now. So every single min times. Oh, but don't you have? Don't you want to do? Oh yeah, I guess min times the this would be the minimum value of the destiny itself. It would actually no. It would always choose the other one because it's the minimum. Why would I do this? I have to override it only if the adding part. So maybe I don't have to do the minimum here and just do min times destiny plus the pair one, which is basically the weight. And then I do this destiny part here, added to this minimum, and then let's say if at some point the next item tries to override this minimum destiny, the first thing we have to check is this specific thing from the next one. So there will be something like an if, that if the minimum destiny, so if this specific min times pair 0 plus pair 1, which is a weight, is bigger, is smaller. Oh, because I'm simulating the same behavior as like the from the source. Oh, sorry, is this the source? No, this should be the source. Oh, wait, this pair would be min times pair. No, sorry, my bad. This is not here. This should not be here. It should be min times plus that weight here. Here. So in this pair, we have basically the destiny, and then we have in this one the other pair is basically the weight, right? So for each operation I'm doing in the queue, we want to find the minimum time for each of them for the specific um destiny. So in order for me to update properly, for example, for this case of min 4 and then this min 4 thing, this one we want to find we're finding the source is basically source 2, its value destiny is 4. So in that case, that means, but and in this case also you have BFS 1, where we have the minimum 4, which is a destiny. So we want to be able to not to override the minimum values only, right? And not override it with bigger values in case it runs afterwards, right? So for that, for in order for me to not override, we beforehand, I have to check the current minimum time and compare it with the like the one that like the value you want to update with before doing the actual update. Sorry. Yeah, so that would be able to I would be able to do it by using like the min times. Let's say I'm just gonna do Cylindrical for now. Min times destiny, because that's the value we're gonna overwrite. They might, yeah, definitely might overwrite, and then that one I would compare with the source, the current source that I have, like min times source plus the current source, like the one inside the like this main BFS. And then this source itself, we would add it by the min times, oh, sorry, not min times. It would be by the pair 2, which would be the weight in this case. So in this case, it would be the other way around, I guess. It would be more like if this min time, yeah, if this min times is bigger than this one, that means that this value itself, our minimum destiny, could be overwritten. That's what we want at the end, right? Like this one to be min times source, and then this would be plot pair 2. Would that make sense? Yeah. Yeah.
Great. So okay, so I'll stop you there. Let's talk about some questions and feedback before we kind of go any further.
Mhm.
Um, just a moment ago there, I did add, and the reason I want to stop you here is because we're a bit over time, right?
Yeah, yeah, no, I get it.
Most of the time, the interviewer will not. First of all, they wouldn't prompt you on the last bit there like I did for help, but also they wouldn't usually let you go on for this long. But before we go into
Mhm.
my feedback, I want to ask you first: how do you feel this went? Did you feel like there were any gaps? Well, like what went well, what didn't go well? Let's hear your thoughts first on that.
Oh yeah, definitely. No, I feel like I was really rusty. I hadn't actually prepared for this. I was trying to see what my level was at this point, since I haven't like done any leak code in like 4 months since I got the internship. But I think I definitely should have like prepped a little bit more. Like I don't know how I missed some really how really easy implementations. So yeah, definitely not my best moment, but I guess that's how you learn though. I'm glad to see a little bit of reality here.
Great, yeah. Okay. let's just go through some feedback then. I'll send you the notes afterwards, but a couple of things just right off the bat. So,
Yes.
most of the time they do interviews at, by the way, I'm still indexing this based on your original, as a request of like intern, medium, hard, that kind of area. Most of the
Mhm.
time, especially if you're trying to test collaboration and communication skills, which is what you have put in for your category as well. Most of the
Yeah.
time, the key there is going to be regarding, are you able to understand the problem? That's question one. Do you understand the problem, right? And why is
Yeah.
that so important? It's important because understanding the problem is a different skill than solving the problem. And they're two different skills, right? So
Mhm.
so 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 don't get it mixed up. And it's important to understand it because, well, a couple of things. First of all, you waste a lot of time solving it if you don't understand the problem, right? And the second one is, if you don't ask the right questions, you might fall into a trap, right? And there's a couple of
Mhm.
skills in here which you can practice later on. The easiest skill, actually, the easiest way to practice this is to get your friends to read legal problems to you verbatim. Like, don't be creative like I am. Just read the problem straight, and
Mhm.
then you understand. You try to figure out what they're trying to ask, and you compare notes after.
Right.
Hey, was this actually what I was trying to say? Right? Like, what questions could I have asked to have understood what they was really trying to mean? Right? So like that's a
Mhm.
different skill. And by the way, in OAs, yeah, it's gonna be written like you see in LeetCode, but in real interviews, it won't be written. Like they will be dictated, most of the time because this is a skill they want to test you on. So just be aware of that. That's the first thing I want to just call out.
I agree.
Uh, okay. Uh, you were talking early on about a brute force solution. Was not clear what that meant. And I think that was because you did not write anything on the page. Right? So I didn't really understand what your level of understanding was. I didn't understand the direction you're trying to go. So generally speaking, it's good to write your notes, write your thoughts on the page as you're thinking them, so the interviewer can kind of tell, hey, where are they lacking understanding? Where are they good? Where are they bad? Where can I help if I wanted to help? Right? If you don't put anything on the page, there's no way they can help.
Yeah, I
Uh,
agree. Yeah.
yeah, you had a good yeah. So you had a good walkthrough of a trivial example. It's always good to walk through a trivial example. I would also encourage a walkthrough of a non-trivial example. You know, one where you, for example, in my case, you had to overwrite the weight. That would be a good thing to walk through as well. Uh, hit given, yeah. So I gave a hit regarding flood fill. So this is the first time. So you asked for a hit. That was good. That was appropriate. The flood fill hint. So again, I don't know your schooling background. I don't really know your academic background. Um, in the graph world, there's a lot of these common operations, which are like keywords. Like for example, you must know BFS, DFS. You might even know Dijkstra's, right? But there's also these themes, like for example, flood fill. Flood fill being one of the themes that really hints towards BFS, right? So why is flood fill important in this context? Because this problem is basically a very very standard BFS problem where you can essentially just get by writing a straight BFS, right? So when interviewers are given hints and you don't understand the hint, make sure you ask if you understand what a flood fill is. Make sure you're on the same page there. So that's the first thing I'll say. Another thing about BFS is that you seem to not have realized that a BFS does guarantee the shortest path solution, right? So if you do BFS correctly, it does guarantee the shortest path solution, but there's a couple caveats. The first caveat is that you have to track your own edge weights. So you figured that out pretty quickly, so that was good. Right? Now, the exact mechanism at which you track the edge weights, you didn't seem to be very clear on, so I gave you a hint about using the minimum times array. And so that seemed to be like just the one piece of understanding that you were lacking. So for practice, I would say, yeah, first of all, get good at writing BFS. Just practice that. That's the thing to practice. And second of all, get good at knowing the limitations of each of these traversal mechanisms. Right, so get good at knowing the limitations of BFS, DFS. This problem really was calling towards Dijkstra's as well. Dijkstra's would have been quite a bit more efficient in terms of time. I mean, I know we didn't do time and space, we ran out of time, but this is a problem that would have definitely benefited from a bit of Dijkstra's as well. So I think part of the solution, part of what I would consider a quote unquote perfect solution would have been calling out all these different options. Hey, we're gonna use BFS here, but I recognize DFS could work with a visited array. I recognize that a Dijkstra's would be optimal with a visited array. And if you're really really fancy, for example, if this was like a leetcode hard, or not leetcode hard, but if this was a hard variant of this problem, it would be the exact same problem, but I would expect more advanced algorithms to come out of it, right? So Floyd-Marshall, Bellman-Ford, that kind of stuff, right? So this is a very simple problem. It's basically a leetcode medium, but there's a lot of skill expression available, right? So the learning here really is to get the fundamentals straight. You have to get the fundamentals straight, and then once you get that straight, then it's a much easier time to build on top of that. Okay. Other notes are very simple. I won't talk about them live, but do you have any questions before we call it?
Um, no, not really. Like, yeah, I agree with lots of the points there.
Okay. Then thank you for joining us, and I'll catch you in the future. Thank you very much.
Yeah.
All right. I'll be 1 minute, and then we'll start with the next person. All right, we're back.
Hello.
Hello, how's it going?
I'm good. How are you?
Good to hear. Yeah, I'm a bit sick right now, obviously, but I'm doing fine. I'll make it through. Great. So you're logged in. Potato. Okay, great. Let me just double check my spreadsheet. Make sure we got the right level here. So, doing intern, easy elite code, focusing on technical execution. Does that sound right?
Yeah.
Okay, great. Have you done graph problems before?
Um, yes, some,
Okay.
but I don't think I'm that good at them.
Okay, no worries. Let me grade one. Well, then that'd be a great thing to test, wouldn't it? All right, great. So, I mean, you are a repeat customer. You should know how these things work. But just as a quick summary for everyone else, this is an hour session, about 45 to 50 minutes of execution. I'll help you track the time since you're not focusing on that aspect today, and we'll get right to it. So,
Okay.
did you switch language? Oh, you did. Okay, we're doing Python. Okay, sounds good. So this is a problem where I would like you to write me a function called valid path, and it returns a boolean. The inputs are going to be a integer in, a integer source, and an integer destination. These are all nodes, by the way. Nodes are represented by integers. And then you're going to be given a, let me just say, what is this type called in Python? I guess it'd be a list of integers. Of
Wait, sorry. We're getting a list of integers?
you're getting a lot of stuff. So you're getting like
Okay.
four parameters. No, yeah, four parameters. You're getting in, which is an integer representing the number of edges, the number of nodes. Sorry, the number of nodes. You're given a source, which is the integer. This is a node. So nodes are integers. You're giving a destination, which is also an integer.
Okay.
Okay, and you're also given a list of integer, and this is a list of edges of the graph. Okay, and so how this list works is this is a list of two long lists where the elements are the source and destination nodes. And you'll be given a list of these lists. Does that make sense?
Wait, can you repeat that?
Yep, no worries. So you get one of the parameters given is a list of integers, which represents the edges of the graph. Okay, and so one edge is defined as a list, where the first element is a source node, and the second element is a destination node. That's right. Yep, and you're given a list of these edges.
Okay.
Okay,
Okay.
and you are to return true if and only if there is a path between the source and destination.
Wait, sorry. What does the first parameter integer in
Oh,
represent?
it's a character in. It represents a number of nodes in the graph. You may or may not need it. That's up to you. Because you
Okay.
can deduce that by processing the edges if you choose to.
Okay. So, okay, just to reiterate, so this represents the total number of nodes.
Yep,
The
that's right.
source and destination, are these node structures or are they just integer values?
No, no, they're just integer values. So
Okay.
you have a node that's might be called node 1. You have a node that might be called node 17. The value of the node doesn't matter. We don't care about the values of nodes. We only care about the structure of the graph. So you can think of these as as like IDs almost.
Okay. And then this list of integers
Hmm.
is a list of edges that look like this, and
That's
then
right.
each of these are just values as well.
Yep. These are both
Okay.
ID integers. Yep. That's right.
Okay. So we want to determine if there is a path between source to destination.
Yep.
Okay. Okay. Um, Maybe let me think of an example first. So if we're given source one destination five, And then if we have like an edge, so like an edge would be like this. And then if we have like another edge, that's like, so then this would be a valid path, right? Because we have edges, and then at some point there exists a path between 1 and 5.
Exactly. Yeah.
Okay. I see. Okay, maybe. Okay, maybe it would be helpful if I build like an adjacency list where I map each node to a list of nodes that it's connected to. Like if I, so like if I have, okay, wait, I have a question.
Yep.
Uh, Wait, never mind. Okay, so if I, so mapping, like in this case, I'd be mapping 1 to 2, and then 2 to 3, and then 3 to 4, and then 4 to 5. So I guess I could just, okay, but then we could also have like other edges. Like a node can be connected to more than one edge, more than one node, right?
Yeah, definitely. Yep. It could
Okay.
also be connected to node like to no other nodes. It's also possible.
Okay. So what if I just iterate through this hash map, starting at the source, and then perform like a traversal on all of the nodes that it's connected to? So in this case, if we're starting at 1, then I would start at the first node that it's connected to, 2, and then I would look at this node's connections, which is 3. So then I would keep um, following the path that we're on until we reach the destination, if it exists.
Okay, that's pretty high level, but I think you're on the right track.
Okay. Um, okay. But then, how would I do this?
So you're definitely right in starting with the source node. That definitely makes sense. Um, right? And so let's say our source node, your example is 1. So you know from 1, you can get to 2 and 3, right?
Yep.
Right. And
Yes.
so you know that wherever you can get from 2 and wherever you can get from 3, you could also get from 1.
Yep.
So you essentially want to say, hey, at my current situation, which let's say is 1, I can get to 2 and 3. And at any current situation, I can get to the nodes in my adjacency, nodes. So like what do you want to call it? Adjacency list, graph, whatever, right? That's fine.
Mm-hmm.
And that means that if I start at my source and I only go to nodes which I have access to, then if I reach a node, any node, I know that I must be able to have gotten it from my original source, because that's how, because like from logic, we know that we only went to nodes that we had access to at any given time. So if we ever access
Right.
our destination node, that means we know it must be possible.
Right. That makes sense. So then if I ever encounter a node that is equal to destination, then I can return true. But how would I detect if how would I know to return false? Would it be like,
Hmm.
okay, so like say this edge doesn't exist. Like if this wasn't here, then I wouldn't have this in my adjacency list. And then I would end up at this node, starting at 1 eventually. And then I would try and check if 4 exists in my adjacency list. And it doesn't. Wait, actually, I have a question.
Yep.
Should I be like, so like right now I have it as like a like one-way edge.
Okay.
Are these nodes supposed to be like this, like both of them are connected to each other, or is it only like one directional?
That's a great question. It is bidirectional. It is bidirectional, but for this problem, it wouldn't actually matter.
Oh, okay. So then that means that I would also have like 4 pointing to 3.
Yes.
Oh. So then, and if this is what my adjacency list looks like, then once I get here, then I'm gonna go to 4, and then I'm gonna check that 3 is there, but then I've created a cycle for myself.
Hmm.
So,
How do we detect
I
cycles?
mean, like, if, I don't know, like,
Yeah, no worries.
if there's, yeah.
Yeah, so if we, let's say we start at 1, we go to 2 and 3, 2 we go to 3, 3 we go to 4, and 4 we go to 3, right? But we already visited 3.
Oh, yeah.
So is there a way to
So we
say,
could just, like, if I have, like, a visited set, then I
hmm
could just store the nodes that I've already visited in this set, and then I'll only visit it if it's not in the set.
yep.
Okay. So then I'll have like visit, and then as I'm traversing, I'm visiting 1, 2, 3, 4, and then I go to 4, and then I see that 3 is already in visited, so I don't visit that. And
Yep,
then,
exactly.
okay.
But you still haven't
So
answered the original
then,
question
okay.
of how do you know there's no path between the source and destination.
Yeah, and
So if we have,
that
so
is,
if you start at 1, this is our, we can say this is our, our adjacency list. We start at 1, we visit at 1, 2, 3, 4, right? What other nodes
yep.
can we visit starting at 1?
Oh, we could visit 3.
But we have already visited 3.
Oh, yes, we have already visited 3.
Yeah. So
That's
like,
true.
what other nodes could we possibly visit starting at 1? Is there a way to go to 5? I mean, you said in this example, there's obviously no way to go to 5, right?
Mhm. There's
So
no way to go to 5.
yeah, exactly. Yeah. So how can we tell that just looking at our code though, right? How can we know that we have no more nodes that we could possibly visit? Because after we go here and we visit 4, right? And then of course at 4 we check if 4 has any adjacencies. 4 has no valid adjacencies, right? Like this is but it's not valid. It's already been visited, right? So our last
Hmm.
node that we could possibly go to it has no valid adjacencies. In other words, we've exhausted all possibilities starting at 1.
Yeah. Would it make sense if, like, after we visit a node, we delete it from the adjacency list? So then if we encounter an empty list, then that means we can't visit any more nodes.
Well, we don't need to delete it. Let's not do that yet, right? If like you're basically just redoing your visited array again, right, or set again. So we can just use that to track what we visited. But in addition, when we want to track what we visited, we want to track what we can visit next. Okay, so from node 1, what can we visit? So I'll
Ooh.
also say so let's try an example, right? So this is our state. Our state will have a visited, and our state will also have, what am I doing? We'll have next. Okay. So at state we're looking at so our source, right? So our source is 1. Okay. What is our visited set at this time? That's empty because we haven't visited anything yet. Right?
Right, yeah.
Well, maybe you can put
Right,
1
right.
in there because it's our starting point, right? So we visit our starting point. Okay, right? So what can we visit next at 1? How many options are there?
There's 2 options,
There's 2
2 and
options.
3.
Yeah, so there's 2 options. So there's 2 places we can go. What am I doing? There's 2 things we can do next from node 1,
Hmm.
right? And then, okay, well, we haven't found our destination, right? So we got to keep going. Okay. So what's the next state going to be? So next state is going to be the next, so our first. So let's say we take 2 first. Without loss of generality, we could just take the first option, right? So now we visited 1 and 2. All right, and we just visited 1, right? So we just visited 1. I mean 2. Sorry, we just visited 2. So 2, we can't visit 2 again
Yeah.
next, because there's already a visited set, right?
Uh-huh.
So 3 is still an option, right? We haven't visited 3 yet. 3 is still an option, right?
Yeah.
Well, what other options have you unlocked by being at node 2? Is there any new options?
No, there's only 3.
Yeah, there's only 3 because add 3 is already in our next array, so we don't have to add it in. So yeah, nothing to do here, right? Okay, great. Moving on. Now we take 3 because there's the only option right now. So we take 3. We visited 1, 2, 3. Okay. At 3, do we unlock any new options?
4.
Yep, 4. So we have 4 in our options now, right?
Okay.
And then now we're at 4. We visited 1, 2, 3, 4. At 4, do we have any options?
3.
Yep, we have 3, technically speaking. But we don't have to add it to our options because we can check the visited set before adding it, right? So
Yes.
we don't actually have any options.
Sure.
Okay, so we start at 1.
Okay.
We have visited all the nodes we could possibly visit. There's no more options left.
Right.
What does this mean regarding the destination node?
So that means we cannot visit it because our options is now empty.
That's right, exactly. We've exhausted all the possible options from starting at source 1, and we still have not visited our destination node.
Okay. That does make sense. So in terms of this next structure,
Mhm.
do you think it would make sense to use like a queue to add like nodes in there so that we process them in the right order? And then at the end, like if the queue is empty, then
Mhm.
that means that we cannot visit our destination.
That definitely makes sense.
Okay. So, okay. So I'm gonna, okay, let me write down some steps. So I'm gonna start at source, add its neighbors to queue, and then I'm gonna iterate as long as queue is non-empty, add its edges to the queue, and then uh, add its edges to the queue along with visited. So as I'm visiting nodes, I'm adding the nodes edges to the queue, and I'm also adding the current node into visited, and then I'm gonna check if destination is reached and then return true. And then if we never return true and the queue is empty at the end, then we'll return false. Does that make sense?
Yep, sounds like a plan.
Okay, I will get started then. I'll call it valid path. So we're passing in n, and then a source, a destination, and a list of integers, edges.
It's a list of integers, right? But yeah.
Right, yeah, a list of integers. Okay. So I'm gonna build the adjacency list, which will be I'll use a hash map. Oh, can I use this?
Yeah, you can. You have to import it though.
Okay. Collections? Is that how it works?
Yes, it is. Yeah, that's right.
Okay. Okay, so then I'm gonna iterate through the edges. So I'll do for node 1 edges, and then I'm gonna add it to the hash map. I'm gonna map this node to node 2. Okay, so then now we have an adjacency list that looks like this.
Mhm.
And then I'm also gonna add visited set, and we want a queue. So I will declare that. Okay.
You need to import
Okay,
that as
so
well.
we want to start from the source. Oh. I don't actually know this import.
It should be from collections as well.
Deck?
Yep.
Okay. Okay, so then we want to start at the source. So I guess I will append that to my queue. And source. Okay, so then now our queue. So like if we're using this example, then my queue would just have one in it.
Mm-hmm.
And then I'll also append it to visited dot add source. Okay. And then I'm gonna iterate as long as the queue is non-empty. So while queue, I'm going to pop from the queue node equals, and then I will add all of its neighbors. So I'm gonna do for neighbor in adjacency list at the node. I will append that to the queue. Append neighbor. Okay, so in this case, now the queue would have 2 and 3.
Mm-hmm.
2, 3. Okay. I guess like before I append neighbors, I could also check if the node we just popped equals destination. Then we return true because that would indicate that we've found a valid path from the source to the destination.
Yeah.
Okay. And then okay. And then I need to add these nodes to visited as well. So I'm gonna add that. I think it makes sense to do it here because after we've popped from the queue, then we've visited that node. So I can do that.
Fair enough. Yep.
Okay.
And what if it is visited? Then what do you do?
Oh yeah. Um, I guess I could check that here, like before adding a neighbor, I would check if that neighbor is already in visited, then I would not need to add it. So if neighbor in visited, or I'll do not in. Wait, yeah, if it's not in visited, then we're appending it to the queue.
Mm-hmm. Okay.
Okay. Okay. So as we're doing this, we are appending all the neighbors, and then at any point, if we reach the destination, we're returning true. And then at the same time, if we don't have a valid path, then this queue would eventually become empty. So then I think at the end we would return false.
Cool.
I don't think I should be adding the source here because I will do that once I'm inside this loop. So I'm gonna delete that. Yeah.
Okay. Are you done?
Okay. Maybe I should run through this example again just to make sure.
Yeah, that's a good idea. Let's do that.
Okay. Okay, so I'm using this as my example. I'm gonna let me finish building this. So 2 is actually connected to 1 and 3, and then 3 is connected to 2 and 4, and then 4 is connected to 3. Okay, so this is what our adjacency list looks like. I'll just put that like here. Okay, so then I am appending the source to the queue, so that's 1, and then I'm doing while queue, and then I'm gonna pop from the queue, so 1, and then I'm also going to add to my visit set, and then I'm checking if the node that we just popped is destination. It's not, so then I'm gonna get all of its neighbors in the adjacency list, which are 2 and 3. And then I'm checking if they're in the visit set. They are not, so then I'm going to append that to my queue. I'm going to append both of them to the queue, and then I'm going to pop the 2, and then I'm going to add it to the visit set, and it's not the destination, and then I'm going to add 2's neighbors, which are 1 and 3. 1 has already been visited, so I'm only going to append the 3. Wait a minute. Append 3. Wait, that kind of does not make sense because the 3 is already in my queue, but it's also the neighbor of 2. So it doesn't really make sense to put it there twice.
That's true, but does it do any harm?
I mean, it's kind of weird because I'm processing it twice, which means I'll be adding its neighbors twice as well. So I don't know.
Okay. How can you prevent adding 3 to the queue?
I could just like if I move this inside here. Wait, let me think. If I move this inside here, I think that would prevent that, because then when I'm at the 1, I will have added both the 2 and the 3 to the visited set. So then once I reach 2, it's already in visited, so I don't have to append it again.
Yep. Yep. That would work.
Okay. That makes sense. Then I guess I do need this here. Because I need the visited set to start with 1.
Mm-hmm.
Okay. Okay, anyways, where was I? So I'm at 1, I'm appending 2 and 3 to my visit set. And then wait. Sorry, my Siri just went off. Okay. So now I'm gonna start again. My queue looks like this. I'm starting with 1, and then I'm adding its neighbors. And then I'm popping the 1, and then I'm going to 2 and 3, which have been added to the queue. And then I'm looking at 2's neighbors, and I'm not appending these again because they're already in the visited set. So then I'm popping the 3, and then I'm checking its neighbors. The 2 has already been visited, so then I'm only going to add the 4. And then the 4 only has a 3, but that's already in the visit set, so then I don't do anything. And then this will return false after the 4 has been popped. So I think that makes sense. And then if there were like another edge from like, what was it, like 5? Then I would append the 5 to the queue. And then once we pop the 5 here, then we check that we've reached the destination and return true. I think that makes sense to me.
Yeah. Okay. Yeah, that makes sense to me as well. Let's talk about. Excuse me. I think this is getting to me. Let's talk about the time and space complexity of this algorithm.
Okay. So in terms of time complexity, uh, okay, so this is happening in, so this will run, um, this, like the length of edges, like however many edges there are, which, how many edges can there be at most? Let me think. So at most, we would have like all of the nodes connected to each other. Um, what? Okay, so then,
That's true, but what is this condition? So I guess this is two
okay,
things here, right? So the first thing is time and space complexity to generate your adjacency list. Okay.
yeah.
So let's talk about that first.
Um, that is interesting. Uh,
Interesting. I
I
have
don't
a
really know how to
okay.
describe this. Like,
Okay.
how would I know? Okay, so
Okay.
if we're given n nodes,
Okay. So we have so
uh,
let's call this we have n nodes and m edges. How's that sound?
okay, let me write that down. N nodes and m edges. Then this would run in O of m time because we have to iterate through each of the edges.
Okay. Okay.
Oops. O of m. Okay. And then
And then
for
space
this
complexity.
part,
No, hold on. Before we move on, what's the space
oh,
complexity of this guy?
um, so for each, uh,
How many keys in your dictionary?
I'm gonna have n keys
Okay.
because there's n nodes.
Yep. And then
So
for
then it
each
would be O of n
and then
for
for each
space.
and then for each key, how many values are in your list?
Would be up to m edges.
Well, m edges in total.
Oh, yes.
So what's
But,
the
okay. Uh, would it be n plus m?
okay? Okay, let's talk about the rest of the algorithm then. So time and space for the rest.
Hmm. So I'm iterating through this queue, but at most, the queue, like each node will only get processed once. So the time would be O of n for each node. Um, yeah, I think that makes sense. Because we're only adding each node once and like we're checking if we've already visited it, so that will prevent us from adding it more than once. And then in terms of the space complexity, uh, we're adding it to the queue. So if we have like a node that's connected to all of the other nodes, then the space complexity could be at most O of n if we have to add all of the node's neighbors into the queue at once.
Okay.
And then the visited will also be O of n because we will have visited all of the nodes by the end.
Okay. Um, we'll comment on that later. For now, let's go for a follow-up question because we actually have some extra time. Um, now let's mod up. So first what we'll do is we'll just save this thing. So let's copy it and make a new one. Oh, what did I do? Whoops. So let's copy this and make a new one. Like so. Go valid path 2. Now I want you to modify this. Oh, wait, no, I want to modify this function to not return a boolean, but to return the actual path.
Oh, okay. Uh, okay. Let me think. So I'm starting at 1, and then I'm going to 2, and then I'm going to 3, and then I'm going. So I'm processing the nodes in this order, which is the order at which I'm adding them to the queue. So I guess like I could also have. Wait, do we want to print this out as an array? Like, is that how you want it to be represented?
You can return it as an array of numbers. Yeah, that's fine.
Okay, yeah. So as I'm building this queue, I could just add each of the nodes to the array, but would that always work? Like, because like I could be going down a path, but it's like the wrong path. So then I would need to delete from my array.
Yeah, the array wouldn't be correct in that sense.
Um, hmm. Yeah, I don't think it makes sense to use an array. Um,
So one thing to note here is like your queue is was previously storing a node,
yep.
right? How about we store paths instead?
Oh, I see. Okay. So then if I were to store the path that we're going down, it'd be like 1, 2, and then 3, 4, 5. But I could also be going down like 1, 3, 2. What if there's like multiple paths that lead to the destination?
You can return any one of them.
Hmm. Okay. Okay. Um, but if we're storing paths, then how would I know when to pop from the queue?
Sorry, say the question again.
If I'm like storing the paths
Uh huh.
inside this queue,
Yeah.
then how would I know when to like pop from the queue? Like, how would I know what node I'm currently at?
Well, the last node in the current path is where you're currently at.
Hmm, true. And then once, I guess like the stopping condition would still be the same. Like if the most recently appended node is the destination, then we just return the path.
Yep, that's very similar. Very similar stopping condition. Yep. So the thing you would change here is well, obviously to change this code probably, and you would probably want to rename this variable, and then we can go from there. How's that sound?
Okay. So, okay. Wait, but why why? Oh, wait, because I'm now appending a list. So I'm gonna be
Yeah,
like
exactly.
list. Okay.
Okay. And then?
Okay, wait. So then instead of popping this whole list, I just want to pop the last element, right? Or
You,
like I
you
don't
still
want to pop it
you
because
still want to
I
pop the
just need to
list.
access it.
Yeah, I
Oh,
mean, you still want to pop it because you want to re-add the list on later.
oh, okay. I'm gonna pop it. I'll call this path then. If so, then instead of checking the node, I'm checking the last element of path.
Yep.
If the last element is equal to destination, then I'm returning this path, which represents the array of the nodes in the path. And then for each neighbor in the last element's adjacency list, I'm checking if it's not visited, and then I'm adding. Oh, wait. Was I always adding node? I think I meant to add neighbor.
Yeah, it's fine. You were, but it's fine.
Okay. Okay. Then I'm going to append to the queue. Wait, what? Let me think. Undoing. So I'm appending to the list. So that would be like that, I think. Would this queue ever contain like multiple paths?
It definitely could.
Mm,
I mean, we have like so you already popped the path off the queue.
uh-huh.
So to make a new path, we want to add our neighbor to this path, and then
Oh,
push the
right.
entire path onto the queue.
Okay. And neighbor. Okay. And then I'll append the path instead.
Okay.
Okay.
Any concerns with the solution?
Um, like, I don't really know if this condition makes sense because if we have multiple paths, then like those paths can have like the same node in each of those paths, right? Like, I don't
That's right.
think it makes sense to have like one global visited set.
Yep, that's a good intuition.
But like, how do I fix that? Like, that doesn't even make sense. Uh, um,
Do you have any ideas for how to fix that? If you don't, we'll move on. But
I don't know. Like, maybe if like each path had its own visit set.
okay, that's one way. Yeah, but let's not do that. That's too complicated. Okay, let's call it here. Let's call it here. Go over
Okay.
some notes, some review, and then we'll talk about it. How's that sound?
Yeah,
Okay.
sure.
So I mean, you know the drill. First thing I always ask is, how do you feel? What do you think went well? What do you think didn't go so well?
I mean, I needed some help on a lot of things because I'm not really familiar with graph questions,
That's fair.
but um, I think once you gave me some hints, it made sense. It was okay.
Yeah. Okay. No, I think that's a pretty accurate general assessment, right? So obviously you were unfamiliar with the graph space, and that's fine. But once hints were given, you were able to pick up the hints pretty quickly, and that's a very positive sign as well. And also, one more thing that was good was that you spent time to understand the problem and to to figure out exactly what we needed to do to accomplish that. So I think that overall I think is a good sign. Um, yeah, so the first problem is, and this is a pretty general class of problem, which is basically finding properties about a graph, right? So basically all graph problems are some variation of this kind where there's a property about a graph, in this case, are two components connected, are two nodes connected, etc. Um, and it all comes down to various different algorithms you can apply to this graph to find the solution. And depending on other properties of the graph, different algorithms might be more or less efficient. So that's kind of the skill curve, you could say, of graph problems. The first problem was a pretty standard, I would say, path finding algorithm, right? But in this case, you don't actually need to find the path. You can just find any path, right? And so, and again, you weren't familiar with this, and that's okay. But the hints I gave were essentially the intuition for how a breadth first search would work. And I was very careful to not use any of that terminology, but instead to just explain how things would happen under the hood. And I think this is how effective teachers teach it anyway. So, keyword teachers aren't in my opinion, aren't it. But, right, so the intuition I gave was about, in this case, how you might have these two pieces of state, right? So if you scroll up again, these two pieces of state, so the visited and the next arrays, or sets, what do you want to call them, right? And after this intuition was gave, you seem to understand how we should, interact with these two pieces of state. So I think that in itself is already really encouraging that like you were able to kind of carry that torch forward from that point, right? And you actually had some pretty good questions. Like for example, a question you had that was good was, what if there's a cycle? That's a very good question. Now, obviously, it's better to ask that before we get there. It's and this is true for all types of problems, by the way. Whenever you see a problem of a certain class, there should automatically be questions that come out. So, for example, for graph problems, things like, for example, is the graph directed? And this will be asked: can the edges go both ways? This property is called directedness, right? So this is a question you should always ask: is the graph directed? Does the graph have cycles? Are there weights? Are the weights be negative? Right. So for graphs, there's these set of problems. For example, questions where the return value is like a list, there should be like, hey, does the ordering matter? Does this matter? What type is the element in the list? And so these kind of things, right? So as you get more and more familiar with graphs, you should get more and more familiar with the types of questions you should ask right off the bat. Because for more complicated problems, the difference between knowing and not knowing these properties could be a very, very big difference maker, right? So, but that's not really a slight. I think you get better at that as you practice. But I think just based on what I've seen today, there's already good intuition based on that. Okay, so yeah, and another piece of this one I saw was that you decided to use a queue for the next array. Now, for the specific problem that we were working on, it actually doesn't matter what type you used. You could have used a set as well. That would have also worked. But because you used a queue, I said, oh, okay, well, she understands what we're trying to accomplish here. We want to, go in order because, that prescribes some efficiency. That makes sense. And because you used a queue, I thought, hey, it'd be appropriate to ask the follow-up question like I did because that one also benefits from having a queue. One thing I will also encourage you to do, which you did do, but I would encourage you to do it even more, is when you're writing a solution note, like in your first time, and you weren't sure what things were happening, I would definitely encourage you to do what you did, which is when you wrote these comments, kind of telling yourself what state these should be in. And I'd say, especially for when you aren't familiar with a problem or a type of solution, it's really, really good to spend time doing that. Like it's not a waste of time at all because, well, first of all, it helps mitigate against bugs. But second of all, it also really helps. It saves you some time later on when you do like a walkthrough of the test case, right? So it's definitely not a waste of time to write those things down.
So you mean I should be doing this like while I'm writing out the solution and not just at the end?
Yes, if you're not familiar with it, right? So for this
Okay,
problem,
right.
which you weren't familiar with, it's definitely okay to do that because you would have done it anyways afterwards to walk through the solution. So
Right.
I think
Yeah.
it's a pretty good use of time. Okay, excuse me, get some water. Give me a second. Okay. Time and space complexity. So, it's a bit off. It's a bit off. Obviously, I think okay. There's two things to say here. First of all, is if you go and study graphs, people I recommend this to people like just memorize the time and space complexities of all the common algorithms, right? So this is a BF. This is a very very standard breadth first search. Breadth first search complexity for time and space is edges plus nodes. And I recommend people just memorize it because you're gonna fumble when you're trying to figure it out, right? But because you didn't know that,
Okay.
I think you did pretty good considering the fact you didn't know that, right? So for example, I'll give you a couple pieces of intuition off the bat, right? So when you generate the adjacency list,
Yeah.
one thing you forgot to take into I give you a bit of a hint, but I don't think you picked this one up exactly, is that the space complexity is the space complexity of this adjacency list, right? You have in keys, which is correct. You have in keys, and then for per key, so it should be right. So you have space in, so you have in times space per key, right? Space per key, right? So how much space
Right.
are you using per key? Well, I told you there's m edges. There's m edges, right? And so on average there should be on average should be m divided by n, right? Uh, Edges per key because there's m edges in total.
Oh
So
yeah.
right,
Yeah, I see
so
what you mean.
yeah, so some details there that you can definitely expand upon. Now, in general, if you weren't given some hints about this one, yeah, just go memorize this kind of thing and don't figure it out on the spot, right? Because first of all, it's a time saver, and second of all, if you're not gonna like, okay, I should be clear about this. BFS in general is edges plus nodes, but there can be restrictions or special assumptions given on a certain problem, which can make the solution much more efficient or much less efficient. So the v plus. Oh, and by the way, it's usually notated as v plus e. V being the number of nodes, vertices, and e being the number of edges, right? But n plus m is fine. I just use the same v
Okay.
plus e, right? But if you start from the v plus e as like a base, and then you say, oh, it's v plus e typical for BFS, but we have a special condition here where blah 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 blah, so it's actually v plus log e or something, right? And so, so start with the basics and then say, hey, is my problem different? Did I do anything different in my BFS? And if so, then you can change it. If not, then it's just v plus e. In your analysis, oh, I don't see where analysis is anymore. So one thing you forgot to account for in your analysis for the time complexity here again, by the way, is it's in nodes, correct? It's in nodes, but for each node, you also have to scan through the entire adjacency list, even if it is already added to the visited array. You can't know that before looking at the adjacency list itself.
Oh,
So that's a factor you
true.
forgot there. So that's why yours is too low, and it has no m in it, right?
Okay.
Obviously, the number of
So
edges does
then
matter.
should the time and space complexity all be like n plus m
Yeah, overall, this
for
problem
like
will be
both
n
of
plus
these?
m. Yeah.
Oh,
I want to spend a bit of time here before we run out of time to talk about the second follow up, by the way, and then we have time. I'll have time for you to ask questions, but I want to get to this question because
okay,
these
yeah.
two kind of things kind of are symbolic of the two types of graph traversals, right? So one type of graph traversal is X possible? Is this property possible? Right? That's the first question we asked. Right? The second question is, if it is possible, give me the actual solution. Right?
Right.
And that is a subtle difference, right? You can see it's basically the exact same algorithm, right? Basically the exact same one, but you can see the queue, the state is different, obviously, and of course, some things are also different in the context of why we're doing something. So you did again, very good intuition. You noticed that the neighbor check doesn't really make sense because we can get to the same quote unquote neighbor from different paths. So again, that's very good. That's very good
Yeah.
intuition, but you didn't quite have the intuition then to how to solve it. So I see you're about halfway there, right? So, but that's a good sign because once you do study it for real, then it should come pretty naturally, right? But why do I bring this one up? Because this is a common follow up problem. Like not this one specifically, obviously, but if a question is phrased as like, hey, return a boolean if X property is possible. When you're asked that question, you should be prepared for a follow up of like, oh, okay, the follow up, the very very easy and common follow up is like, oh, now actually show me the real solution, right? And why do I say that is because
Right.
part of the solution there is like, do you recognize that it's the same problem, it's the exact same thing, but the state is different. It's the only thing that's different, right? So whenever you're studying these graph problems, you're studying these solutions, be very very clear what the state is, because that will be the only thing that varies. The algorithm, BFS, DFS, Dijkstra's, Bellman-Ford, all these things are the same algorithm across all graphs, right? It's just that the state that you track is different. So this problem and of course I gave you a bit of hint on this one. We want to store the path instead of the node. Once you recognize that, and that will come naturally as you study the problems. But once that hint was given, you were able to solve it basically by yourself, right? And so just recognize that that's a very powerful piece of insight, is that, there's, every time you're asked, hey, is something possible? The second question will be like, okay, now actually do it, right? So this is your basically your head first dive into the deep end for graph problems. I think, considering you haven't seen these kind of things before, I think you did pretty good. So, pat on the back for that. Good stuff.
Wait, is this considered an easy question? Because I feel like it's kind of hard.
This would be considered an easy question in the graph world, but graph questions in general are harder than other questions. So this would be considered easy graph problem,
Yeah.
but probably like a hard tier easy or an easy tier medium in the space of all problems.
Right. Okay.
Yeah, and it definitely felt hard because you didn't know about this pattern, like the pattern of set up the adjacency. I mean, you knew this one, but you didn't know the pattern of set your visits at your queue and then do this immediately, right? So a problem like this is a very, very, what I call a pure problem, where there's the only thing that's being tested is purely your ability to regurgitate a BFS. Now, that's accounted for in the difficulty ranking because people who do these kind of problems know BFS, like they know the thing very, very well, right? But if you don't know BFS, then it is going to be a much harder problem because you had to build this without the intuition of BFS. So that's why it felt hard. But know that once you start doing more and more of these graph problems, this type of pattern is very common, and you'll find it easy after a while.
Like, okay. Can I ask questions now?
Yeah, of course. Yeah, go ahead.
Could you also solve this using DFS, and would that be better? Or
Yep, you can solve this problem using basically any traversal. So any of the graph traversal algorithms would be able to solve this correctly. The only difference would be the efficiency. So, um, so yes, you could. So yes, you could use DFS. You could use BFS. You could use Dijkstra's. You could use a bunch of there's a lot of algorithms you can use. A star's a one. There's like a bounded DFS, stuff like that. Like all of these are all possible. It's just a matter of, do you recognize which of these is the right choice to use for the particular problem.
okay, would it be like more or less efficient if I used DFS?
So in this case, it would really. So in this case, it's not clear because I didn't give you enough information. So you would have to, for example,
Oh,
know the light. So the difference in DFS is that it could be better space complexity if the path is short. It could be. So by path I mean the final solution. So but because that's all information that was given, you can't assume that. Right, but for example, if you knew these items, you might ask, "Hey, do we know anything about the length of the path?" You might ask that. And now, obviously, I wouldn't tell you because that's not the problem. But right, but you could ask that, and I say, "Oh, this person's smart. They're considering using that. They're considering using that." So there are different trade-offs for that kind of thing. But in this particular problem, the answer is no because they didn't give any information.
okay. Also, like, why did you give me N? Because I didn't even end up using that. Would there
Uh,
be like a solution where I would have to use this variable?
yes and no. There's a couple things that the reason that you might use in is because look at your adjacency list. Your adjacency list is mapping a node, which is an integer, to a list of integers. You instead could have just defined your adjacency list as a list of, how do you write a list again? Is it like this?
Yeah.
So you could
Yeah.
have just done that instead.
Oh.
Oh no, not that. Sorry,
Oh.
I meant this. No, wait, wait. Oh, yeah, how does Python work? You know what I mean? Like you can make it. Oh no, I think it's
I see.
this, right? I don't know, but
Yeah,
you know
I
what I
think
mean. Like you
so.
could have done this, right? Some languages
Oh,
this would have
okay.
helped you. Would have helped, but yeah. So yeah, again, right? So and I by the way, I copied this signature right from LeetCode. So this is just a signature that's given to some languages, which might find that useful. But yeah, like and you'll see this sometimes, and I gave you this hint specifically because I know you're doing Python, but I said you might not need this variable because yeah, you could calculate it if you needed to. You could calculate it by processing the edges anyways. So it wasn't needed, but it's still provided.
Okay.
Okay. Anything else?
No, I don't have any more questions.
Okay, cool then. Then let's call it here.
Okay, cool. Thanks for having me.
You're welcome. Thanks for participating.
Okay, cool. See ya.
See ya. All right. So, um, I know we're starting the resume reviews pretty soon. I am going to go ahead and get that loaded up. Oh, my cough's getting to me. Ah. Where is my freaking what's it called? Resume. Yeah, here we go. Boom. Let me just put boom. Resume reviews starting soon. Submit your resume in Google form. Stream description. Okay. I'm gonna get some water. I will be right back. All right. All right. I'm taking a look. Yeah, we got one. Let's take a look. Made the changes you suggested previously. Want to get your feedback? Okay, let's take a look. All right. Okay. This is for what? Full stack. I mean, you didn't say it, so I'm assuming full stack eng. Okay, so architect implementer. Okay, what is this? This is software developer. Okay. Adapting quickly to enterprise development practices. What does this mean? Like this doesn't mean anything. I would say be careful saying stuff like this because it's not quantifiable and it's not that relevant. Okay. Otherwise, it feels like a bit of a mishmash of things, but this is like a, for example, like a contract based position. This is fine. Totally fine. Oh, AI ML industry job. Oh, you gotta say so, dude. You didn't say so. If you don't say it, I assume everyone's going for full stack eng. But all right. AI ML industry. You're definitely good to focus on these two. I would say again, missing the how. Right, like how. How did your solution achieve 90% accuracy? What was the thing? Was it for example, like what classification are you using? You know, random forest, right? Like any boosting, right? So it's missing the technical details. It's only the what. There's no how for both of these points. Why is the date underneath the achievements? That's you putting this date underneath this. Doesn't make sense. We have a okay. Through innovative model architecture. Yeah, explain what was innovative. Like what did you do? What was in there? Right? Like summarize. Advanced instance segmentation techniques. Like what? Like what? You have to write it down. Like this is your, you have a paper here that's published. This is the only thing here that holds any weight. You have to elaborate on this. I would probably put 6 points in this one. Plant trace predictor. See this one you said it's innovative. Now you said how here. Like this makes sense. So this is a good. This here is a better point. AI powered language translation system. Okay, that's fine. That's fine. Yeah, so this thing needs way more expansion. There's no detail in this one, and these 2 points also lack in detail. I would say those definitely need a bit more work. But I would say, I mean, in general, I would say it is a case that like you have to, you have to be careful about the image you kind of give off. ML industry, right? They're gonna want to see you have some academic skill, but they also want to focus on like your like actual ability to implement stuff. Whereas, for example, this point is good, right? It shows a bit of implementation detail. This point, like, yeah, you did some stuff. You improved classification. Definitely did some stuff, but there's no there's no detail here. So people who are serious about this kind of thing, they actually know the details of these kind of things. So, like, that's what they would be expecting. So if you don't meet their expectation, it's not like it's good. So be careful about that. Okay, let's take a look. All right. No one else in the no one else submitted through the form, so I'm gonna get some from the Discord. Here we go. University Guelph. So this person's comment is looking for backend suite in the SaaS space. I wrote a second sections in. I just wrote the second sections in experience. What? Okay. Well, like feedback on that in particular. Do any error there is blah, 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 blah. Okay. Okay. So this is fine. Node expression. Development tools is not formatted correctly, but yeah. Blah blah blah. That's fine. Okay. Continuous integration testing. Yeah, I'd say. Oh, I'll just write some letters for him. Code coverage 7%. This is software engineer full stack. Okay. Okay. Anything with unit testing, I would say either don't put it there or put it at the very bottom. That's such a worthless point to put in the first thing they read because that's not the right tone you set, right? Result discrepancies distributed, blah blah. Okay. Okay. The previous other big okay. Data size 1%. Low around these. Okay, this is good. Been here for okay. So like half a year. After coming on a year. Okay. Part time. Oh, okay. Interesting. Okay. Okay, interesting. So this sounds interesting. This sounds like a pretty good thing for like a new grad. Do you new grad? What are you? You have like a new grad. Yeah, I'm like this sounds pretty high leverage. Not bad. Get a back to CSE. Okay, great. What is this? Tool assists with daily data performance. Okay. It's just developer tooling. Okay. Okay. Unit test, man. Unit test at the bottom. Improve visibility for communication with the computer nodes, life cycle as well. Blah. Okay. Paralyze 8,000 lines. Okay. Sure. I probably wouldn't characterize the complexity by line count. I feel like that's probably not the right, not the right. So like more lines doesn't mean what you think it might mean. So I'd probably get rid of the 8,000 lines. I would instead, just leave it as I think just leaving like this as context is enough. It's fine. This is co-op. This is for the university. Processing pipeline. Blah 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 blah. Okay, this is fine. Lowercase p. Image processing project PL. Okay, nice. Yeah, it feels alright. It feels a bit simple to be honest. I feel like compared to your current experience, there shouldn't be that much. But what else I would do? I would expand on this one. Expand on the API point. I would expand upon this point over here, performance point. Specify that one. Because you're looking for back end or full stack. We see back end, so performance is a big thing. I want to talk about that a bit more. I think then depending on a focus on whether or not you're really good technically or really good, let's say socially per se. You want to go for like the team player kind of thing. This would be very good to expand upon, right? What talk about some initiative, like why was this work that you took on? What how bad was it before, etc. Right? There's also one about manual work, right? Was there one about manual work? I forgot. Right, so that might be one good to kind of expand upon, and you can fill up a couple bit more space there. So I think that's where I would go with this resume. But yeah, I think resume is honestly decent enough overall. I don't think there's anything drastic you had to like change. Okay, let's say this guy. All right, this guy. All right, so this guy's comment. Trying to get a first internship, software engineering. Okay. Okay, so like a second, third year kind of area. Do have some of 4. Okay, so projects, technical skills, a lot of stuff here. Languages, Postgres is not a language. Bash, LangChain, PyTorch, JavaFX, NumPy. Okay. This is fine. That's fine. All right. Engineer. Excuse me, I'm sick right now, so I'm coughing up a storm. Sorry. All right. All right. So, engineer Python movie recommendation system, PyTorch, okay, that's okay, blah blah. Okay, accurate. You got to quantify that. What percent was accurate? Optimized query or something 40% is vectorized operation. Okay. This is overall okay. You know, this is kind of riding the hype train a bit, but again, you gotta understand that, like, in terms of, just a competition wise, this kind of product doesn't really say anything. Like there's really not much skill on display here. So I would be careful about over-indexing on stuff like these AI kind of projects. One thing I will also say is, like, dates are doubly important because you have nothing else to index on. So dates are important, and GitHub link preferably. Electronic store app, JavaXX, it'll just check it. Okay. MVC improved code readability, one of the for checkout systems. GUI. Yeah, so this is gonna be a bit weaker. I feel like. Yeah. Okay. Let me read the rest. Launch point C. Whoa. Spacecraft control system C, dynamic arrays, linked list, 1200 sensors, improved simulation consistency. Okay. Okay, this is a good first point, by the way. Team, multi-thread data, 7.4, space conditions, fast synchronization. Okay, makes sense. Event system, dynamically adjust spacecraft really quickly. Okay, yeah. So this is good. This makes sense. This is the best product I've seen so far. So I say, if this is a more recent product, bump it up. This is a good one. Definitely you can put some points here. I think these 3 points are pretty good. Automobile dealership simulation. Okay, so this is just not it. So I say this is the best, this is second, this is third, and this is fourth. Okay, so what I would say here is that put some more points here. Talk a bit more. Where did Linux and Bash come in? Right? So here you didn't say anything about Bash scripting. So put a point about that. That could be better. Right? This thing really does not need 3 points. That's really kind of a weaker project. This is also a bit weaker, I'd say. So don't spend much room on that. That's not a use your space. Now, in general, I'm gonna say this every single time I have opportunity to, okay? You want to get a job, no experience passed. What you need is a full stack web app. That's what you need. Okay, go make a Twitter clone. Go make a Discord clone. Go do something. Go make a YouTube clone. You need a full stack web app. That's what you need. All right, moving on. Jesus Christ, why is this small text two pages? Okay. Oh my goodness. This is my friend's resume. She wants to get some feedback as well. Full stack dev? Why is this resolution so small? Again, okay, let me go all the way to form. Why do people not fill out the form? What the hell? This is my form. I think I need to move this one up. Should I break this out into like a separate like checkbox? Like have people fill out what role they're going for? People never fill this in and they get upset at me when I comment on the resume for something that's unrelated. How crazy is that, by the way? I wish I could have like a minimum word count. You have to write 50 words or I won't review it. All right. Okay, let's take a look. That's a lot of pages. University, Fraser Valley. Okay, so you graduated. So not graduated yet. Okay. Okay, so like 4 months. 4 months. This is, what is that? 5 plus 3, 8 months. Okay, you've got less. You got about a year of experience. This is not related. You got a year of experience. You do not. You cannot have 2 pages. Okay, I'm gonna tell you just right off the bat. No one's gonna read this. Just straight up, no one's gonna read this. This is just way too much stuff. Okay, so let me tell you what to cut. Okay. You're not graduated yet. This should be near the top so people know what's going on. Okay, let's take a look. Team management, dynamic removing employees, blah blah. Local state. This is irrelevant. This is basic React. This is basic React. Okay, this is like a general basic front end kind of project. This one line max, if you want to even put it in. What is this? Stock prediction app, Python Visual Studio. What? Python Visual Studio? That's crazy. That's it. Okay, so this is a team project. Okay, so the technical side of this is not that relevant. The technical side is not relevant. If you want to if you want to describe what you've done in terms of the prediction algorithm, that makes a lot more sense, right? If you're using the stock prediction app to describe business analysis, that is not the right. Like this is a mismatch in expectation. Okay, like this is not like you shouldn't be using the stock prediction app to talk about things like, for example, deploying. Like that's not that relevant, right? And never talk about patterns. If you talk about patterns, you're lost in the sauce, right? Like you're completely lost in the sauce. The resume is not the place to call out patterns that you know. Okay, this is not the right kind of place for that. If you want to put these library names down, put the libraries names down in your skill. Where's your skill section? Okay, you don't have a skill section. Okay, use the skill section. Okay, get a skill set. Okay. Okay, I don't know how people have not seen this yet. Okay, but if you're not using this resume, you cannot be complaining to me. Okay, so go use this template, and then come back. That's what I'll say. Okay. What else? Okay, and what were the patterns? Surpassing prior research results by 1,800%. You would need a set of paper for that. This is completely unbelievable. You need a set of paper for that. Okay, so IT technician. For a software full stack, this is I would say the amount of space it should take is just a header. None of this is relevant. Just put the header down. Okay, so people know that you have employment. Now again, you were only employed for 3 months, so depending on how desperately you want to communicate that, you might not need it. But like none of these would be relevant. Okay, so let's move on. By the way, don't need that. This information should be inside the relevant experiences. Okay, so these two are your experiences. If these points don't fit in here, they don't fit at all. Okay, so you don't want to just have random points that are just floating around. Okay, organize Cloud County data, save as dashboard, generate CSV page recheated. Okay, conduct seamless data analysis. What does that mean? What is seamless data analysis? Like seamless is not an adjective to describe data analysis. Okay, like this is not quite there. For managerial decision making. Okay, if you want to talk about how you were able to do data analysis for management, you shouldn't be talking about doing data analysis for management. You should be talking about how your data analysis enabled management to do something that they couldn't have done otherwise. Otherwise, your data analysis was useless, right? So this is missing the critical piece, which is like, okay, and then what did they do with it? So they made decisions that did what? That increased revenue, that did this, that did that, right? So you're missing and then what happened piece, okay? Do not talk about Agile, do not talk about Scrum, do not talk about, okay, so this is not relevant. Document user requirements, perform quality check. Okay, so this should be one line max saying, did QA, like this, like I would say this should not be testing. This should be inside of the PR reviews. It shouldn't be inside the QA process. Don't use such as. Just use in. WordPress is one word, I'm pretty sure. Don't talk about unit tests. Don't talk about regression tests. Okay, so I think these two words, you just polish them up, it could be okay. Okay, let me see. From these, anything else that were relevant? Monitor. Okay, so this is already captured by the first point here. Hands-on experience. This is never talk about design patterns in a resume. Full stack web Scrum. Don't talk about Scrum. Scrum is not relevant because that's not a skill, right? Scrum and Agile aren't skills. In other words, has anyone failed to do Agile? No one has ever failed Agile because it's just such a trivial thing that everyone could just do when stay on board. So if it's not something which is impressive, which is not something which sets you apart, don't talk about it, right? That's another way to look at the resumes. QA stuff is already covered. That's covered as well. I told you about that. So if you cut all that down, it should be about 1 page max. It should fit pretty comfortably after that. Okay, moving on. Uh, okay, this guy is okay. So this guy's cool. This guy said mobile dev. Okay, mobile dev. All right, so I like mobile dev. Mobile dev, manage iOS, Android. So something take a look. So this is presence. This is a little while. This is before that. 2 internships, 2021, mathematics 2022. Okay, got it. So a couple years of experience now, right? So this is like couple years. So a couple years of experience. Okay, got it. iOS, Android app releases, App Store, Google Play Store, Fastlane. Okay. Okay, interesting. So we're talking about deployment management first. I would probably not put that first, but maybe that's a skill. Maybe that is a skill. Okay. Led the independent refactor of ticket setting systems to $800 revenue. Okay. That's great. Okay. That's good. Oh, that's good. Cocoa Paws. I don't know what Cocoa Paws are, to be honest with you. This is good. This is also good. Okay, all good points. I would probably just rebalance this, so I'll put this one just somewhere down here. I don't think this is as impressive as like some of these guys over here. Okay, build the foundation to the. This is a different place. Yeah, probably okay. Okay, great. So this is quantified. Very good. I like that. I like that quantification. Launch native mobile authentication products in the React Native SDK. 250K, also good. Revenue. I love revenue. If you can connect those numbers, love to see it. That's great to see. Really good to see those numbers. Excuse me. Oh, the coughing's into me. Blah 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 blah. Okay, that's fine. Blah blah blah. That's fine. Yeah, I mean this kind of stuff, like support, like reducing support load I think is a big positive. I think it's underrated. I think that's underrated as a data point people talk about. So I think this is good. Right? Just say I think it's good. I think other people don't think it's good. I think it's good. So, I'd say that's a good point. But some people might disagree. Stream package, blah blah blah. Okay, this is less impressive. That's fine. This is okay. That's okay. Yeah. Oh, okay. That's great. I think this is actually very cool. That's very good. Okay, so you're saying, looking for mobile dev roles. A couple things here I'd say, probably. You're on the right track. There's a lot of pretty good data here on the resume. I would say at this point, you should be pretty focused on, so I don't know I don't know. So this person didn't say why they're getting a resume review. They didn't say they're having trouble. They didn't say it's easy. So I don't really know where they're at, right? What I will say is I think the resume is fine. I don't think there's anything wrong with the resume. I think the data's all here. I don't think the resume is a problem. I would be surprised if this resume is not getting a half decent callback rate. But I think overall it's quite fine. It's totally fine. Okay. Yep, makes sense. Okay, let's take a look. A lot of resumes are actually reviewed. I'm trying to find one that hasn't been reviewed, so might be useful. What is this resume? That one looks reviewed. That one looks reviewed? Not sure. Sometimes people don't open a thread. Sometimes people just make a just respond to it later on, and it's not. I can't find the original. Let's see what else is there. Oh, F's fuck. Yeah, that's reviewed. Dude, the community is pretty good at reviewing resumes. I have to say, they're on. I'm scrolling about like 4 days now. Yeah, I think everything back here is reviewed. I think so. Okay. Then what I'll do is I will hang out in this stream. Waiting for resume submissions. Form. Check pinned. I will take a quick break, get some water, and maybe get some medicine too. I don't know. And I'll be back in like 5 minutes or so, and I'll see if there's any new submissions. If there's no new submissions, then I'll probably call the stream here. I'll be back in 5 minutes. We'll be back at 13:38 Pacific. BRB. I'm back. Oh my god, I immediately started choking up again. I'm back. Did you guys miss me? No, no one missed me.